I'm going to look at some MCQ questions just to refresh our brain on what we should expect under general anesthetic. Just few questions I selected out, though not from the beginning. Before I got this concept. So the first question here we have is, which of the general anesthetic is most potent of the inhalation anesthetics? Now the one that is most potent is also have the tendency of being most toxic, right? So the one that is most potent of all of them, this is the nitrogen oxide, this is propane, this is ethylene, this is chloroform, is B, which is cyclopropane. Cyclopropane, okay, supposed to be not propane, supposed to be C3H6 because it's cyclopropane. So it will have the formula of the alkane, general formula of what? CnH2n, and not the full-blown formula of alkane, which is CnH2n plus 2. So it's supposed to be C3H6. So, but among all the general anesthetic, the one that is most potent of inhalational anesthetics is what? Is cyclopropane. You know, general anesthetics are classified into inhalational anesthetics, and then we have the what? The intravenous anesthetics. Now, the next one. Which of the general anesthetics is less potent and less toxic of the inhalational anesthetics? Now, the one that is less potent and less toxic is the nitrogen oxide. Alright? That one is less potent and less toxic. Now, which of the following is used with barbiturates and other volatile anesthetics to produce surgical anesthesia? Is also the nitrogen oxide, because it is less potent and less toxic. Are you getting it? And hence it is reacted with barbiturate and other volatile anesthetic. Now write the sentences. How do we synthesize this compound? One way to synthesize it is by the breakdown of what? Ammonium nitrate. So when this breakdown is going to give us what? N2O plus, what do you think? HNO3. Are you sure that this is what it's going to give to us? NO2 plus HNO3 or NO2 plus H2O. NO2 plus H2O. Alright, this is one of the methods for synthesizing this compound. There are other methods for the synthesis, which I just feel this one is very, very okay. But the equation is not balanced. How do we balance this equation? You can put two. Are you sure it's not HNO3? You might be actually right. HNO3. So we have two molecules of H2O here. This is one of the methods for the synthesis. However, there's another method that involves this compound here, which the name is more like a sulfamine group, all right, plus nitric acid. Now this is going to give us N2O plus H2O plus H2SO4. Any of these means can aid us to synthesize this compound in question. You can see here, all right, but it is the least potent, and hence it is used with barbiturate and other volatile anesthetics to produce surgical anesthesia. Next question. Okay, it's still the same thing. That was used during the World War I, causing over 85,000 deaths. The correct answer is phosgene, and this is phosgene. This from the oxidation of chloroform, you get phosgene. All right, oxidation of chloroform, you get phosgene. Now, next one. Write the mechanism of reaction for the synthesis of thiopental. How do we write the mechanism for the synthesis of thiopental? First of all, we have to draw the structure of thiopental. How is thiopental like? Think thiopental is, we have something like this. How does the structure of thiopental look like? Think we have something like this. Is there supposed to be nitrogen here? Then we have double bond oxygen here. Okay, here is X. Then here is double bond oxygen. Here is double bond oxygen. Then we have something like this here, which is 5 membered ring. one, okay, supposed to be one CH3 up, then 1 2 3, something like this, 1 2 3 4 5, and then you have C2H5. This is the structure of thiopenta. So we want to synthesize thiopenta. Now, how do we synthesize this compound thiopenta? It's very easy, because we have H here. We are trying to practice this one. Now we use dimethyl malolate, and is it dimethyl malolate or diethyl malolate? So it's something like this. Which we have double bond oxygen, and then you have OC2H5. Yes, OC2H5. Now that is the first thing you look out for. All right, the name of this structure is called, this is dimethyl malonate. Okay, diethyl malonate. Now you react dimethyl malolate with this compound. Now you are going to write this structure again, this particular part of the thiopenta. You see how we can synthesize, you just break it down. You write this particular structure again, but then at this tip here you put bromine group here. So here will be bromine, all right, and then you are going to have something like this, like this, like this, and then you have something like this. This you pass it with sodium ethoxide. All right, now when you pass this with sodium ethoxide, it's going to give you a product. Now the product will be such a way that you have this group here, pick this group out, which is something like this. You know that this C double bond O and OCH3, it can also be written as COOC2H5. This group here, also C double bond O, OC2H5, can also be written as what? COOC2H5. And then you are going to attach this part to this part of this ring. Is that okay? So this is going to be attached to this part of this ring. So if that happens, this is what you are going to get. We're going to get something like this, like this, like this, like this, and then you have this group here. Now, have you gotten to this extent? What do you think is the next thing you can actually do? Now, at this point in time, the next thing you can do is to add the ethyl group. So we want to add ethyl group. How do you add ethyl group? You add ethyl group by passing this sodium ethoxide, also C2H5, which is the base, and then using C2H5I. All right. Now, at the end of the day, this one will attach to this position also to form 4 bonds. So we are going to form something like this here, which should be something like this. Here will be COOC2H5. Here will be COOC2H5. It's still the same thing, whichever way you want to draw it. So we'll have something like this, and then you have the ethyl group attached to this position. Plus, the next thing now is thiourea. Now, what is the structure of thiourea? It's more like urea. Urea is NH2 C double bond O NH2. This is the structure of urea. So if you want to write thiourea, it will be X. In place of this O, you put X, and then you have what? NH2, and then you have what? NH2. So that is where these 2 nitrogen are coming from in this ring. So when you look at this ring, remember that you have 2 nitrogen, right? 2 nitrogen, then sulfur is in between the 2 nitrogen, and then you have 2 oxygen. The 2 carboxyl group are this and this. So you actually see where the whole thing is coming from now. All right, so this will give us the desired compound, which is something like this. All right, double bond O, double bond X, NH, double bond O, and then you have something like this, and then C2H5. If they give you tau Miller is just like the same sentences, but the difference is that tau Miller have an allyl group at this position. So you have CH2, CH, double bond CH2. So it means as this position where you have C2H5, what you be having is CH2, CH, double bond CH2. It means where you have this C2H5, what you'll be putting there is what? CH2, CH, double bond CH2. Is that okay? So that is that for the synthesis of tau penta. It's very, very important you take note of it. All right, now let's see the next synthesis. The most widely used intravenous anesthetics, of course, is tau penta. That is the most widely used. What is the estimated onset of action for tau penta and duration of action respectively? Now the onset of action is 30 minutes, while the duration of action is within 10 to 30. Onset of action is 30 seconds, while the duration of action is within 10 to 30 minutes. That is option C. 30 seconds, 10 to 30 minutes. All right. Now, okay, it's still the same question. Discuss the SARO of morphine and related compound. I believe everybody must have known the SARO of morphine and related compound. The most important thing I want to tell you here is this. When we talk about SARO of morphine and related compounds, the first thing you need to look out for is there will be eterification of this OH. And if you eterify this OH, because numbering is 1, 2, 3, the OH is also called phenolic OH. Please take note. This OH is also called phenolic OH. If there's eterification, it leads to what? Decrease in morphine-like character. Are you getting it? Morphine-like properties, like all those nausea, vomiting, hallucination, delirium, GIT depression, and the rest. That is one position you modify. Another position you modify is this position. You can modify here. You can also modify here. You can also modify here. You can remove this ring here. So these are the various positions. So when you draw the structure of morphine, if they like this, you give SARO of morphine and related compound, you'll be able to give 5 by this group here, this group here, this group here, this one here, this one here. This is already 1, this is 2, this is 3, this is 4, this is 5. You know that removal of this ring here is not, this group here is not important for what? For what is it called? It is not really important for morphine, for analgesic activity. That is what this one is all about. Then all these ones are eterification, esterification, acylation, and so on. Then this one is depending on the length of the ring, you may have agonist, antagonist, or a mix of agonist, antagonist action. But you must have read this SARO of morphine related compound, so we don't really need to waste much time here. Now, I've answered this question in a separate video. All right, which of the following is a narcotic antagonist? Now the narcotic antagonists we have are the ones where this group here, the arrow group here, is longer than 3. When the alkyl substituent here is longer than 3, they have agonist antagonist action. All right, when it is between 3 and 5, it has agonist antagonist action. Now let's look at example here. This is morphine. Of course, morphine is an agonist. Levofenone is an agonist. All right, these are the 14 hydroxy derivative. All right, okay, no, this levofenone is the levo isomer of the morphine, right? Now this levalofan has an allyl group. When we talk about allyl, we are talking about something like this attached to this arrow group here. This arrow group, what you have for levalofan is an allyl group, so it is an antagonist. I told you that when the chain length at this position is within 3 and 5, then it is an antagonist. If it is less than 3, it is an agonist. All right. So this levolofan, levalofan is a narcotic antagonist. All right. Natrazone, nazolone, all those ones, they are all what? Antagonists. Now, discuss the 14 hydroxymorphinans. Those were the ones we just discussed. Now, when we talk about the 14 hydroxy group, that is where you have the oxylofan and then butofanol, right? Oxylofan and butofanol. Now, oxylofan has this what is it called? Cyclopropyl ring attached. Why butofanol has a 4-member ring, something like this, a 4-member ring attached to this arrow position of the morphan ring. You know, morphan, they will not have this group here, right? This group will be off. Let me just give you the structure so that you know what we are talking about. It's very easy. The morphinans, they are something like this. They have this all right, and then they have OH here. Of course, the phenolic OH seems to be very important for analgesic activity for almost all of them. So you have this group here attached. Now, at this position number 14, this position here is position number 14. If you count, told you earlier that here is 1, here is 2, here is 3, here is 4, here is 5, here is 6, here is 7, here is 8. All right, you don't count here as 9. You come here and say 9, here is 10, here is 11, here is 12, here is 13, here is 14. So at this position number 14, you have an OH attached here. Is that okay? That's what you call the 14 hydroxymorphinans. Are you getting it? Now, when you have this propyl ring attached to this group here, that means if you have something like this, you call it the oxylofan. All right, then if it is this ring you have attached, you call it butofanol. And this oxylofan and butofanol, they are mixed agonist antagonist, because I told you that whenever the ring here is greater than 3 or within 3 and 5, it exhibits that mixed agonist antagonist action. All right, so that is that for this particular one. I don't think I wrote it down. All right, so that is that. Let's see for the next one. Outline the synthesis of adrenaline. How do we synthesize adrenaline? Where do we start from? We start from the catechol nucleus, right? So we have something like this. The catechol nucleus is something like, okay, I don't want to keep drawing this way. We can do it this way also. The catechol, this benzene ring, when you have an OH group here like this, you call it the catechol. All right, so we have the catechol nucleus. After the catechol nucleus, to get the structure, what do we have? We have it added to Cl, CO, NH, and then I think Cl again. Abi? Yes, something like that. Catechol, let me confirm, is excluding me. I actually wrote all these things down. You know, sentences can be somehow, you just forget the starting material. Okay, I didn't actually write it down. I think that is it, because I know at the end of the day another this thing will attach to it. Abi there's CH first. CH2, and then we'll have N, no NA, just CH2Cl, like this, right? So, exactly. So that is one thing that you should also almost take note of. All the starting material for the sentences is very, very important, because once you miss all the starting material, otilo, adrenaline, then at the end of the day we are now having CH3NH2 attached. Abi? So trying to get it straight. So if this one attached, is going to form something like this. This is my final revision for this particular side. You have CO, CH2, and then Cl, and then of course you have OH, you have OH, plus which other one again? CH3 NH2. All right, now this one is now going to give us what? OH. Once you get the starting material right, it will be very easy for you to, this CO, CH2, then you have this NH. The reason is because this NH2 will combine with this group here, so you have H2N CH3. One of the hydrogen from here will combine with this chlorine to form hydrogen chloride, and then this NHCH3 will attach here, so we have NH, and here we what? CH3. All right, now at this point in time, this compound you see here, CO, it means a ketone, but what you have in adrenaline is what? An alcohol. So you have to reduce using what? Using aluminium in mercury. You can use any of the reducing agents to actually reduce this. So when you reduce, here will be OH, here will be OH, here will be C, OH, this is CH, here will be CH2, NH, here will be what? CH3. So this is the structure of your adrenaline. This nucleus here is called the catechol nucleus. Catechol. You see where these OH are adjacent to each other. Is that okay? So that's basically how to go about the synthesis of adrenaline. Now the next one is the synthesis of mepyramine from pyridine. Now if you are asked to synthesize mepyramine, first of all we have to draw the structure of mepyramine. What do you think is the structure of mepyramine? For mepyramine, we first of all have the pyridine, right? Which is something like this, right? And then you have what? N. Then from this one here, from here we have N, and then from here you have CH2, here you have OCH3. It's ethylene-diamine derivative, so you expect the ethylene-diamine ring here, and then of course you have this other group N, and here is what? CH3, here is what? CH3. All right, so I believe that is this nitrogen atom is supposed to be up here because of the way I drew it before. If I had put it here, it would have been correct. You're the one that corrected me and made me make mistake. Your papa. Alright, so that is that. Now this ethylene-diamine ring, ethylene-diamine is something like this. When you have nitrogen, CH2, nitrogen. So we call it the ethylene-diamine derivative. This is structure of mepyramine. Alright, so we want to know how to synthesize mepyramine. Now that you've known the structure, we can now start the synthesis. The synthesis starts by pyridine. So we write down pyridine, which is something like this. All right, we write down pyridine. Now, having written down pyridine, told you this pyridine, you react pyridine through with sodamide. You can go the sodamide. All right, you can go the other route of nitration, then reduction, to give you the amine. Because what we actually try to do here is to add an amine group to pyridine. So if we go by that route, this will give us something like this, and then I have my amine group here. Is that okay? Now we need to add this group here. All right, how do we add this group? We add this group by what? By the reaction of Cl, which is the chloride of this group here, so that chlorine will react with hydrogen, and then we get our answer in sodium ethoxide, which is a base. All right, now at the end of the day, what do you think this is going to now give to us? Now this chlorine will react with one hydrogen here, so it forms hydrogen chloride, and this group will be attached to this position here. Is that okay? So you are going to form the benzene ring, which is nitrogen, and then you have, I said, pyridine ring. Then you have nitrogen, here will be hydrogen, and then here will be what? CH2, and CH3. Here's what? CH3. But that is not all. We need to add this group here. Same way we added this group is same way we are going to add this group. But this group now is the chloride of it that we are now going to write here. So we have the chloride, then you write the entire this thing here, which is CH2, and then here you have the benzene ring, and then here is what? OCH3. All right, what structure do you think? This hydrogen will react with this chlorine here, so it will form hydrogen chloride. So the final structure will be the structure of mepyramine. All right, which will now be what? N. This H will react with this chlorine, so it means we are going to form CH2, which is this, and then you have the benzene ring, which I don't want to go too far, and then you have the what? OCH3, and then here you have CH2, N again, CH3, CH3. All right, so this is now the structure of mepyramine. Mepyramine is our what? Antihistamine, right? Is the ethylene derivative of the antihistamine. Is that okay? So that is that. Let's see the next synthesis. Non-adrenaline. How do we synthesize non-adrenaline? Now, non-adrenaline is adrenaline without what is it called? Without CH3. So in order to synthesize this, we start with our catechol also, but this time you will have CHO here, which is the aldehyde form of the catechol, right? Now after this aldehyde form of the catechol, what do you think we are now going to add to get the structure of non-adrenaline?